afternoon, friends. So we are having a problem on a machine operator who is processing five types of items on his machine each week and must choose a sequence for them. So here the setup cost per change is depending on the items presently on the machine and setup to be made according to the table. That means he has set up his machine what he is having for this particular uh, product, say item number A. So if he wants to change his setup to some other item number B, so it incurred him a cost of 4 units of currency. Maybe it is in thousand or hundreds or tens, whatever it is. So you take accordingly. So for setup cost from changing item A to item A will not incur any cost. So it is instead of keep it blank, so we are using this particular symbol. So changing the setup from product A to product B, so the cost incurred will be 4 units of currency. If it is in terms of tens, it becomes 40. If it is in terms of 100, you take it as 400 like that. Similarly, if the setup is changed from product A to product C, so it will be the cost will be 7 units. Similarly, from A to D, it will be this 3 units. From A to E, it is the 4 units. So, if the setup is made for the item number B, and if he takes again the same item B, so there will be no change in the setup cost because the same setup will be used. So C to C, I don't have any cost. D to D, I don't have any cost. E to E, we don't have any cost. So if the setup what is made for a particular product, if I want to process some other product, so then minute changes will be done in the setup. So then there will be additional cost incurred. So that will be given in this matrix. If he process each type of the item once and only once in each week, how should he sequence the items? So that he has to process all the items A to E at least once. So, but the total setup cost should be minimum. So that is the question. Now, so since it is already the cost matrix, we need not do any conversion. If it is the profit matrix, so that should be converted into the loss matrix or the cost matrix. Now it is the cost matrix given, so directly we go for the row minimization. So select each element, sorry, least element in each row and subtract from the remaining elements from the given matrix so that the row minimization matrix is obtained. So then column minimization. From the row minimization in individual column, take the lowermost element and subtract from the remaining elements. So this first column, second column, fourth column and fifth column we have already zeros, so they remain same. Only in the third column we don't have zero, so the lowermost cost is 1. So you subtract 1 from the other element. So 4 minus 1 is 3, 3 minus 1 is 2, so on. So we are getting the column minimization matrix. So then draw minimum number of horizontal lines or vertical lines to cover all the zeros. So number of lines drawn here will be 5. Size of the matrix is also 5 here. So go for the assignment now. So first assign single zero, that is search each row or column to find out only one zero is present in the column or row. So first assign that particular zero, then the other zeros in that particular row or column must be crossed out as we have seen in the earlier problems. Now the assignment what made will be like this. So that is he was processing the item A, then he is going to the next item, so that is B. So then from B he is going to next item D. So then from D he is going to next we'll see. Here the solution obtained is A to B, B to D, D to A. So that is okay, A to B, then from B to D, and then D to A. So this what the sequence obtained here is not covering all the items. So that is each item is not processed at least once in a week. So hence we will go for the better solution by considering the next smallest non-zero element. So in the earlier matrix what we obtained, so the next smallest non-zero element is 1. So you are going to assign that next smallest non-zero element 1 and cross out other zeros and in ones in that particular row and column. So the assignment obtained will be something like this: A to E, A to E, then B to D, then C to B, then D to A, and then E to C. So solution obtained is A to E, A to E, then E to C, E to C, then C to B, C to B, then B to D, then D to A. So started from A and ending on the item A once again, processing all the other items at least once in a week. So total setup cost from the given matrix. So from A to E. So what is given? So that will be taken. Similarly, the other setup cost will be added to get the total setup cost as 21 units. So if it is in terms of 10, the answer becomes 210. If it is in terms of 100, it becomes 2100, so on. So this is the minimum cost incurred to the shopkeeper so that each item will be processed at least once in a week.